am Shri Jyoti. Welcome to my channel. Today's video is of class 11 mathematics chapter 12 limits and derivatives. It's very important chapter. As we all know, calculus is one of the most important branch of mathematics. So it is the limits and derivatives is the introduction to the calculus. In 12th standard you will study calculus, differentiation, integration and their applications. Okay, now here first of all let us go through limits. So what is a limit? Here we will take a function. Okay, let f of x be a function of x, and if at any point at x is equal to a, this function is indeterminate, we will consider a point that is a point near to a. Okay, it may be less than a or greater than a. Here f of x be a function of x. Okay, and if at x is equal to a, if at x is equal to a, the function f of x is indeterminate, not determinate. Okay, so not fixed. So here in that case we consider a value that is approaching to a, or it is near to or close to a. Okay, it may be less than a or greater than a. Then what is the value of x? So and it is represented as limit x tends to a f of x. That means when x approaching to a, okay, when x approaching to a means when the value of x is near to a, okay, close to a, then what is the value f of x tends to? Okay, so what is the value of f of x? So that is the limit of the function. Okay, we say limit of the function f of x. See here, limit x tends to a f of x. Okay, we call it limit x tends to a f of x. That is when x approaching to a, okay, it may be less than a or greater than a. So what is the value of f of x tends to? Okay, and here let us take one example. See, as I told, the values of x tends to less than a or greater than a, means less than a means left of a. See, it is the a. Okay, let us take numbers. Okay, a is equal to 2. Okay, so less than 2 means, see, nearby numbers, that is 1.98, 1.999, etc. Okay, so here after 2 means 2.001, 2.002, etc. Okay, so here when the values close to or near to a, less than a means, see, when the values here x tends to 2 means less than 2 means 1.999. Okay, 1.999. Okay, so here we say it is left hand limit. Okay, so we write it as x tends to 2 minus. Okay, x tends to 2 minus because here x is approaching to less than a, left of a. Okay, so this limit is called, see here we will write limit x tends to 2 minus f of x. Okay, so this limit is called left hand side limit. Okay, left hand limit. Next, see here when the value of x is greater than 2. Okay, that is when value of x is approaching to greater than 2, that is right side of 2, that means if x is equal to 2.001, okay, so here we write limit x tends to 2 plus f of x. So this limit is called right hand limit. Okay, so as I told, see here x approaching, it may be less than 2, okay, less than a or greater than a. So here let us take, okay, see, it is the limit, right? So limit x tends to a f of x. So here we have to check does it exist or not. Okay, does this limit exist or not? See here, that is if limit x tends to a minus f of x is equal to limit x tends to a plus f of x. Okay, see here the left hand side limit, okay, the left hand limit that should be is equal to the value of right hand limit. Okay, that means, see, here let us take one example. Okay, f of x is equal to x plus 2. Okay, our function is this one. Okay, it is the function of x, f of x is equal to x plus 2. So here when x is equal to 1.98, See, when x is equal to 1.98, that means left hand limit, okay? First we are taking left hand limit, means x is approaching to less than a, okay? Left side. So here x means, see what is the value of f of x? That is x is equal to 1.98. So add 1.98 plus 2, that is 3.98, okay? Next, let us take right limit, okay? So right side of it 2. Okay, so here our function is f of x is equal to x plus 2. When x is equal to 2.001, then what is f of x? Okay, 2.001, substitute x is equal to 2.001. So we will get 4.001. Okay, see here what is the change? See, it is nearby values, right? Okay, so it is approaching to, so these values are close to 4, right? See here, if we take f of 2, see what is f of 2? See, when x is equal to 2, so what is the value of f of 2? That is nothing but 2 plus 2, that is 4, right? See here we have got f of 2 is equal to 4, okay? And when x is equal to 1.98, that is it is very close to 2 and less than 2, the value of the function is 3.98, that is very close to 4, right? And when x is equal to 2.001, that means here the value of x is close to 2 and greater than 2, okay? So in that case, the value of the function f of x, see very close to 4, that is 4.001, that is very close to 4. So here we can say, see, here we can say limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x. That means, see here, our values, f of x values are very close to 4, right? That means, see, here we can say this function is equal to this one. Okay, that means left hand is equal to right hand. In that case, we can say the limit of the function exists. Okay, so first of all, we have to check it, does it exist or not. Okay, so here, limit x, it is the definition. Okay, limit x tends to a minus. Limit x tends to a minus means when x approaching to less than a, okay, left of a. F of x, that is equal to limit x tends to a plus, that means when x approaching to a plus, that is greater than a, f of x, okay. So those values should be equal, then we can say, and it is equal to f of a, it should be f of a, the value of is, this one is equal to f of a. See here, we have got f of a means a is 2 here, okay. We have taken an example, a is equal to 2. So here f of 2 is equal to f of 4. So here it is the definition of the limit, okay. So here limit, that is left hand limit should be equal to right hand limit, okay. Then we say the limit of the function, limit x tends to a, f of x exists. Here we can say limit x tends to 2, f of x, that is x plus 2 exists, okay. Look at this example. The function is f of x is equal to 3x and the function at x is equal to 2. Okay. See here, I have written some values nearby 2. Okay, that is approaching to 2, left and right. Okay. So here, limit x tends to 2 minus f of x, that is 3x, is equal to. See here, we observe that here when the values approaching, x values approaching to 2, this either right and left, the f of x values is approaching to 6, right? See, when 1.9, see, you can take any values, for example, okay, for 1.9. So here 3 into 1.9, we have got 5.7. Okay, so when 1.95, that is also nearby 2, okay. So 5.85, okay. So here, see, when the values of x approaching to 2, either left or right, see, the values of f of x approaching to 6, okay. So here we can write, that is limit x tends to 2 minus 3x, that is equal to 3x is the function, okay. It is equal to limit x tends to 2 plus 3x. Okay, that is, see, when x is approaching to left side, see the values of function, limit of the function that is approaching to 6. Okay, so here also in right side, okay, here also the when the x values approaching to 2, the f of x is approaching to 6, right? So here also that is equal to limit x tends to 3 f of x. Okay, see here that is nothing but f of 2. Okay, so what is f of 2? F of 2 is nothing but 6. Okay, so here we can write limit x tends to 3 f of x exists, because these two are equal, right? Left hand limit and right hand limit are equal. Therefore, we can say limit x tends to 3 f of x is exist. Okay. See one more example. The function, given function is, see here also we have to find the limit of the function, limit x tends to 0 f of x. Okay, so the function is x minus 2 when x less than 0. Okay, and when x is equal to 0, the value of the function is 0. Okay, and when x greater than 0, value of the function is x plus 2. See here, so first of all let us write some values, okay, and x values when x less than 0, x less than 0 means negative values, right? So here we have taken some values that is very close to 0, that is minus 0.1. Okay, so when x is equal to minus 0.1, see our value f of x is nothing but x minus 2, substitute minus 0.1, so that is minus 2.1. Okay, so here next, when x is equal to minus 0.01, value is minus 2.01. When x is equal to 0, it is given that already, right? So f of x value is 0. Okay, next let us take some values that is very close to 0. Okay, positive values that is very close to 0. X plus 2, so x greater than 0, that means 0.01, or you can take 0.001. Okay, 0.01, when x is equal to 0.01, f of x is 2.01. Okay, and when x is equal to 0.1, f of x is equal to 2.1. So it is the function. Okay, so here see, when x approaching to less than 0, okay, when x the values of x less than 0, here f of x is minus 2.01, right? So here minus value, right? And see, f of x, when f of x is equal to 0, when x is equal to 0, f of x is also 0. Okay, and here in positive, that is in right hand, see, when x is equal to these values, we have got f of x tends to 2. Okay, here f of x tends to minus 2, here f of x tends to 2. Okay, so here left hand limit and right hand limit are not equal. Okay, see, we can write limit x tends to 2 minus f of x not equal to, see here it is tends to minus 2, right? So I will write it as minus 2. Okay, when the values of x tends to greater than 2, or we can write limit x tends to 2 plus f of x is equal to that f of x tends to 2. Okay, that is f of x tends to approaching to 2. Here in left hand, the f of x, value of f of x approaching to minus 2. Okay, so here we can write limit x tends to 2 minus f of x does not equal to limit x tends to 2 plus f of x. See, since they are not equal, we say that limit x tends to 2 f of x does not exist, because here left hand limit and right hand limit are not equal. So in this case, in this function, we say the limit x tends to 0. See here, what is f of 0? F of 0 is nothing but 0, right? It's also different. So here we can say the value of the, that is limit of the function. Okay, that is limit x tends to, limit of the function at x is equal to 0 does not exist. Next is algebra of limits. Here we have taken two limits. See, let limit extends to a f of x and limit extends to a g of x exist. Okay, two limits are exist. Then algebra of limits. The first one, limit extends to a f of x plus g of x, that is equal to limit extends to a f of x plus limit extends to a g of x. Okay, that is if two limits exist, okay, then limit extends to a f of x plus g of x, that is equal to limit extends to a f of x plus limit extends to a g of x. Here we can write plus or minus. Okay, so in subtraction also same thing. So here limit extends to a f of x minus g of x, that is equal to limit extends to a f of x plus minus limit extends to a g of x. And next multiplication. Limit extends to a f of x into g of x, that is equal to limit extends to a f of x into limit extends to a g of x. Okay, next one, limit extends to a f of x divided by g of x, that is equal to limit extends to a f of x divided by limit extends to a g of x. Okay, next fourth one, we can write limit extends to a lambda f of x. Here lambda is some real number, okay, that is equal to a constant, okay, that is equal to lambda into limit extends to a f of x. Here we can take that constant outside or from limit. So these are the algebra of limits. Two limits, limit extends to a f of x and limit extends to a g of x exist. Okay, then limit extends to a f of x plus or minus g of x, that is equal to, we can split it, right? Limit extends to a f of x plus or minus limit extends to a g of x. So you have to apply this algebra of limits in exercise problems. So limit extends to a f of x into g of x, that is equal to limit extends to a f of x into limit extends to a g of x. Limit extends to a f of x divided by g of x, that is equal to limit extends to a f of x divided by limit extends to a g of x. Next, limit extends to a lambda into f of x, a constant into a function. So in that case, we can take a constant outside from limits, that is equal to lambda into limit extends to a f of x. Now let us go through some questions. Questions means this here finding the limit of the different functions. Okay. So here to find the limit of the functions, four methods we will apply. First one is direct substitution method. For example, see put r tends to 1 in function. Okay. So you just substitute r is equal to 1. And next second method is the factorization method. Okay. Next third one rationalization method. Fourth one using some standard formulas. Okay. Applying standard formulas. Okay. Now let us go through these problems. Here first one is evaluate limit r tends to 1 pi r square. See, whatever problems comes, you just first of all you have to apply that first method, that is direct substitution method. Okay. So here first one, limit r tends to 1 pi r square. Okay, limit r tends to, not x, r tends to 1 pi r square. Okay, here see direct substitution method. See, put r is equal to 1. Okay, so pi into, when r is equal to 1 means 1 square, that is equal to 1. So pi itself. Okay, see here that means, see limit when r tends to 1, so with the value of r approaching to 1, see here we will find the value of pi r square approaching value. Okay, so direct substitute r is equal to 1. Okay, so here limit r tends to 1 pi r square is equal to pi. Okay, so whatever limit problems, see, if you are asked to find the limit of the any function, first of all you apply direct substitution method. Okay, after that I will tell. See here, we have got this value. Okay, so this limit exists. Okay, so limit r tends to 1, pi r square is equal to pi. Okay, next here second one, evaluate limit x tends to 4, 4x plus 3 divided by x minus 2. Here also we will substitute x 4. Okay, so limit x tends to 4, 4x plus 3 divided by x minus 2, that is equal to, substitute x is equal to 4, that is 16. Okay, 4 into 4 16 plus 3 divided by 4 minus 2, 2, that is 19 divided by 2. Okay, so here second one we have got the value of the limit of the function. So next let us go through third one. Limit x tends to minus 1, x raised to 10 plus x raised to 5 plus 1 divided by x minus 1. Limit x tends to minus 1, x raised to 10 plus x raised to 5 plus 1 divided by x minus 1, that is equal to, substitute x is equal to minus 1. Okay, minus 1 raised to 10 plus minus 1 raised to 5 plus 1 divided by minus 1 raised to, minus 1 minus 1. That is equal to minus 1 raised to 10, since the power even number, so it will be plus, that is plus 1, plus here since it is odd number, it is minus 1 plus 1 divided by minus 1 minus 2, that is equal to 1 minus 1 cancelled, so minus 1 by 2. Okay, so here third one also we have got the value of the limit of the function.